All right, so let's start. So this is the problem solving session for chapter 9. So here you will be using static equilibrium concept and elasticity concept to solve the problem from chapter 9. Okay, so let's start. So the first one, the question number 1 is this one. So the diagram for this problem is this. Okay, the diagram for this problem is this one. Okay, so here we have this object whose mass is 200 kilogram. Okay, so the corresponding weight is 1960 Newton. So you see this is 1960 Newton. That can be determined by using m times the gravitational acceleration. So this and this basically the same thing. So yeah, make sure you don't count double. So use just once. Okay, so one is the mass and another is the weight or the gravitational force. So count this only one time. All right, so this mass is supported by two string. Okay, so the string one is this one, and string two is this one. Okay, so we have to calculate the tension on those strings. Okay, now this object is in static equilibrium, so we can solve this problem by using the condition of static equilibrium. Okay, so what are the conditions? So we learned two conditions. One is f equal to 0, and from this we have basically two equations, fx equal to 0 and fy equal to 0, right? And then we have another condition, and that condition gives us another equation, that is tau equal to 0. So for solving the static equilibrium problem, you will be seeing that most of the time we need only two equations. So here we have three equations, right? So out of three, for most of the time, we'll be using two equations. But there are some complicated problem where we have to use all the three equations. But most of the time, you are going to use only two. Okay. Now in this problem, let's see what we can use. Okay, now before I solve the problem, okay, let's see what we are given, what forces we are given. So we are given three forces here, right? So one is this one is this one, and another is this one. So the good thing is 1960 is along the negative y-axis and FB is along the positive x-axis. So these two forces are good. Okay, I mean, we don't need to do anything. Okay, so we can directly use this in the equations. Okay, but the problem is FA is neither along the x or y-axis. Okay, so how to then solve this problem? So solving this problem is easy. We already know how to break a vector, right? So we can break this vector and then use this in our equations. Okay, so to do that, let me make it little big. Okay, all right, so here we have this. Now let's break this vector into its component. I mean, break FA into its component. Okay, so how to do that? So let me draw a line here. So this is basically the negative x-axis. Okay, and then this is basically positive y-axis. Okay, now when you have a vector something like this, our strategy is starting from the tip of the vector, tip of this vector, draw a perpendicular line. Okay, that intersect a horizontal line. So you see that this is the horizontal, x-axis is the horizontal line. So this is the tip of the vector. From there we draw a line, perpendicular line that connects a horizontal line, and then from the tail of the vector we draw another line that connects the first line. Okay, so then this is parallel to the y-axis, so this is FAY, the y component, and this is along the x-axis, so this is the x component, so this is FAX. Okay, now with this the problem is solved. Okay, now we have to understand that what is this angle. Okay, now here you see the roof is this one, and this is the horizontal or x-axis, and this is the vector. Okay, we know this is 60 degree now because this line and this line are parallel to each other, and this vector connects these two lines. So from geometry you can show that this angle is equal to this angle. Okay, so this angle is 60 degree. So all the problem are basically solved here. Okay, so we know everything now. So this tells us that FAY is equal to FA sine 60 degree. Okay, because it is opposite of the angle 60 degree, and FAX is FA cosine 60 degree because it is the adjacent of 60 degree. Okay, so now we can write the equation. So first let's start with Fy, I mean the condition of static equilibrium. This is equal to 0. So what are the forces along the y-axis? We have Fay along the positive y, and then mg, or actually mg is 1960 Newton. 1960 Newton equal to 0. Now Fay is Fa sine 60 degree, that is equal to 1960 Newton. So Fa is 1960 Newton divided by sine 60 degree, and this is equal to 2263.2 Newton. Okay, all right, so we get Fa. So that's great. Now the next thing is we have to calculate what is Fb. Now Fb can be solved by using this equation. Now along the x-axis we have Fb, and we have also Fax, and Fax. So Fb is basically equal to Fax, and Fax is equal to Fa cosine 60 degree. Okay, so Fa is 2263.2 Newton, and then cosine 60 degree, so it will be 1131.6 Newton. Okay, so you see that here we can determine Fa and Fb by using just the force equation. We did not need to use the torque equation. Okay, all right, very good. Now let's move on. Let's try the next problem. Okay, so before that, let me erase these things and go to the next problem. All right, so this is the next one. So here we have a seesaw board. Okay, two children on two sides. Okay, and the seesaw seesaw is in balance position. Okay, so that means the seesaw board with the children are in static equilibrium. Okay, so we have three conditions to solve the static equilibrium problem, right? So now what are given? We are given the mass of the children and also the mass of the board. Okay, and one more information here we are given is the boy is sitting 2.5 meter from the center or the pivot point. Okay, so these are the given information, and what we have to calculate, we have to calculate the distance. Sorry, so we have to calculate the distance from the center to the girl. Okay, so x here in this diagram, if you look at the diagram, the thing we have to calculate is x. Okay, now if we have some problem something like this, okay, we have to draw a free body diagram. Okay, now free body diagram for the board, the seesaw board. Okay, so because here we are interested, I mean, you see that there are many forces are acting on the seesaw board. Okay, so the first thing is we have to identify what forces are acting on the on this board. Okay, so here is the seesaw board. Let me draw it. So here is the seesaw board. Okay, and this is the center. Okay, so it is on some surface. Okay, although it looks like tipping surface, but it is on the surface. Okay, so this is the seesaw board and this is the center or the pivot point. Now what forces are acting on this board? Okay, so of course it's mass, right? The seesaw has its mass, so there will be gravitational force here, right? Let me use another color. So this is the gravitational force. Okay, so let me call it mg. Now what else? There will be a normal force, right? Because the seesaw board is on some surface. Okay, and this surface will be exerting a normal force on the seesaw board, and that will be this opposite to the gravitational force, and perpendicular to the surface. Okay, so this is the normal force. What else? The girl is here, right? So girl's weight is also be there. Okay, so this is mbg, and the boy's gravitational force also be acting on the board, right? So boy is also exerting some force on the board, and that is mag. So these are the four forces that are acting on this board. Okay, now there you see that all the forces are along the y-axis. Okay, and we are interested to determine this distance. Okay, this distance and this distance are given, that is equal to 2.5 meter. Okay, now there are no forces along the x-axis, so fx equal to 0 is not useful here. Now we can use fy equal to 0, but fy basically relates all the forces. Okay, so n, the normal force, with this and these forces. So in this equation you will see that there is no room for this x. So by using fy equal to 0, we cannot determine x, because fy does not relate x with other known quantities. Okay, so the only thing we can use, I mean only thing we are left with is this one, tau equal to 0. So this probably the equation we are looking for. Okay, so let's see whether we can use this equation or not. Okay, tau equal to 0. Okay, and remember the tau is equal to, so the definition of tau equal to r, the lever arm, the applied force, and sine theta, where sine theta is the angle between the lever arm and the force. Okay, now here you see the all the forces are perpendicular to the lever arm. Okay, so perpendicular means sine theta equal to sine 90 degree, and sine 90 degree equal to 1. So for all the forces, sine 90 degree equal to 1. So our equation for tau is basically r times f. So simple equation. And also remember that for counterclockwise rotation, the convention is to use a positive sign, and for clockwise rotation, the convention is to use a negative sign. Okay, so these are the conventions, so that we have to remember. So once you have all this information, the next thing is to determine tau is to understand the axis of rotation. Okay, so for this problem, the axis of rotation is easy because it's already said that this is the axis of rotation. Okay, so the seesaw board goes up and down about this axis. So here this I mean, it's not a problem. Okay, later you will see that in many problem there is no particular axis of rotation. Okay, so in that problem you are free to choose any point as your axis of rotation. Okay, we'll see later, but yeah, for this problem, because it is easy, let's use this as our axis of rotation. Okay, so if this is our axis of rotation, then r for the force N is 0, right? Because N is here. Okay, and the distance from the axis of rotation to the point of N is equal to 0. So this is our first term. For the second term, mg, for mg, big mg, the lever arm is also 0. Okay, so first two terms are 0. Now for this force and for this force, let's see what we have. Now for the boy, we can write 2.5 meter and then MAG, and for the girl, we can write X and then MBG, that is equal to 0. Now we have to decide what is this sign or what is this sign. Okay, so these two signs we have to decide. Okay, now so to decide this, let's say we have only one force. Let's first talk about the boy's sign for this one. Okay, so let's say this is the seesaw board and the axis is this. Okay, so this is the seesaw board. Okay, now if there is only one force, I mean, if boy just sit here, okay, the seesaw goes in this direction, right? And this is the direction of CCW, counterclockwise. Clock rotate in this direction, right? So if you look at this point, you see that the direction is counterclockwise. So the sign will be positive. Now do the same thing for the girl. Okay, so girl is here, right? Now if there is only one force, that is by the girl, the seesaw will move in this direction. And you see that this is the clockwise direction. So for the girl, the sign will be negative. Okay, all right, now because these two terms are 0, so let me erase this, so and rewrite this equation as something like this. 2.5 meter MAG, okay, minus X MBG equal to 0. Now G is common, so you can cancel out, and then if you solve it for X, okay, so let me do step by step. So this is 2.5 meter MA is basically 30 kilogram, and then x, and then this is 25 kilogram. Okay, that is equal to 0. So if you solve this equation for x, but let me write one more line. So x will be 2.5 meter 30 kilogram divided by 25 kilogram. So if you solve this, you get 3 meter. So the girl sits 3 meter from the center of the seesaw board. Okay. All right. Next is this one. Okay. So a heavy machine is on a beam and on a horizontal beam. So this is the horizontal beam. So this is the horizontal beam, and this horizontal beam then is supported by two vertical beam, this one and this one. Okay. So we know the mass of this beam, we know the mass of this printing, this heavy machine. Okay. And we also know the length of this beam is 20 meter, and we also know that this printing machine is 5 meter. So the center of this printing machine is 5 meter from the one side. Okay, so this distance is 5 meters. So these are the given information. Okay, so we have to calculate the support force, okay, by these two vertical beam. Okay, so it asks us to calculate the force on each of the vertical support columns. Okay, all right. What it means? It means, all right, so it means we have to calculate the normal forces. Okay, so to understand this, first we need to understand few things. So the first thing is the center of gravity. Okay, so by the way, center of gravity and center of mass is the same thing. Okay, so in chapter 7 you learn about the center of mass, right? Cm, and cm and cg is the same thing. Okay, because the center of, I mean, you can get the center of gravity just by multiplying center of mass by the gravitational acceleration. So that's the only difference. But center of gravity basically tells us about the center of the object. Okay, for example, if we have a uniformly distributed object, in chapter 7 you see that the center of mass is the geometrical center. Okay, so for example, if you have a circle, something like this, if you have plate, circular plate, something like this, then the center of gravity or center of mass will be its center. If we have a rectangular object, then center will be here where the two diagonal intersect. Okay, something like this. So here the center of gravity is basically the center, assuming they are uniformly distributed. I mean, the materials are uniformly distributed around the material, around these objects. Okay, so CZ means basically the center of mass, although its name is center of gravity, but center of gravity and center of mass is basically the same thing. Okay, so this is the first thing you need to understand. And then the next thing you need to understand is what force we are going to calculate. So the question asks us to calculate the force on each of the vertical support column. Okay, so it asks us to basically calculate the force that is acting on this column. Okay, now how to do that? Okay, so to do that, first we have to draw a free body diagram for this horizontal column. Okay, so horizontal beam. So this is the horizontal beam, because all the forces are basically interact with this beam. Okay, for example, if I want to know which force is acting on this beam, okay, if we don't consider this big beam, okay, if we don't consider all the forces that is acting on this beam, it will be difficult to solve. Okay, so what we have to do, we have to first understand or identify what forces that are acting on this horizontal beam. Okay, then from some information, from some previous knowledge, okay, we can determine the what force that is acting on the support beam, vertical support beam. Okay, so first let's try to draw the forces that are acting on this horizontal beam. Okay, and then let's talk about this line. Okay, so what are the forces that are acting on the horizontal beam? One is the gravity, right? Gravitational force for this beam itself, so it will be at the center, so this will be the gravitational force. Okay, weight of this beam. So there is a printing press or the heavy machine. So for the heavy machine, we have another gravitational force, and let me call it capital Mg. Okay, so these are the two forces. Now, because this beam is on some surface, right? So this is one surface, this is one surface. So there will be a normal force. So one normal force will be here, and another normal force will be here, right? So let me call it Fa, and this is Fb. Okay, and these normal force are basically exactly equal to the force that is acting on this beam and this beam. Okay, so once we can calculate Fa and Fb, that basically in turn tell you the forces that are acting on the vertical support column. Although we are basically calculating the normal force, but this basically tells us about the forces that are exerting on this support beam, I mean vertical support beam. Okay, so the thing we have to calculate is normal forces, and these two normal forces basically tell us about the forces that are acting on the vertical beams. Okay, all right, so these are the things, given things. Okay, and also we know that the distance from this side to the middle is 10 meter. Okay, the distance from this side to this one is 15 meter. Okay, because we know that this is 5 meter. Okay, so these are basically the given things. We have to calculate Fa and Fb. Okay, so here again you see that there is no forces along the x-axis, so we cannot use that. Okay, so first let's start with Fy. Okay, Fy equal to 0, and we have Fa and Fb, these two forces are positive, and then Mg and Mg are negative. So our equation is something like this. Okay, or M plus M times the gravitational force, and then this is 1500 kilogram, and this is 15,000 kilogram, and this is 9.80 meter per second square. So this gives us 161700 Newton. Okay, so this gives us very important information. It tells us that the forces forces Fa, and I mean the sum of the forces Fa and Fb is this, but we want the individual forces, not the total force. Okay, so we have to calculate the individual force. So what to do that? I mean, what to do to solve that? To solve, we can use this equation, tau equal to 0. Okay, let me use another color. Tau equal to 0. Now here the problem is, what is the axis of rotation? Okay, because it is static equilibrium and there is no axis of visible axis of rotation like the last problem. Okay, so if we have some problem something like this, you are free to choose any point as your axis of rotation. Okay, as we already discussed during the theory, during the lecture. So here I will be choosing this point as our axis of rotation, but you are free to use any point. Okay, you can use any other point and check that the result will be exactly the same. Okay, so let me use this as our axis of rotation, and again you see that all the forces are perpendicular to the lever arm. So again sine theta equal to sine 90 degree, and that is equal to 1. So I'm not going to write sine here in my equation. Okay, so this is my axis of rotation. So for FA, the lever arm is 0, so this is this. Then for MG, it is 10 meter. Okay, for MG, 15 meter for big MG for the printing press, and 20 meter for FB, that is equal to 0. Okay, now the difficult thing here is to determine these signs. Okay, so you see that I intentionally did not write any sign here. So now it is the time to decide what sign we should use here. So let's try one by one. Now let's say, so this is our axis of rotation, and let's say we have only mg. Okay, so this is the axis of rotation, this is the force mg, and for this force you see that it is clockwise, right? It follows the clockwise direction. So for this force it will be negative. Okay, so the sign for this one will be negative. The same thing for this one mg, it will also be negative. I mean, this one and this one basically very similar for the sign, so they will follow the clockwise direction, so that's why I'm using negative. And because FB is opposite of these two forces, it should be positive. Okay, but you can also check by using this concept. Okay, using this diagram. So here is the force, and you see this is opposite of the clockwise. So opposite of the clockwise is counterclockwise, and for counterclockwise the sign is positive. Okay, so these are the things. Now if I solve it for FB, so this is already 0. So if I solve this equation for FB, it gives me, okay, so 20 FB equal to 10 mg and 15 mg. Okay, and yeah, don't confuse with the this is unit. Okay, so let me, so this is also unit. Okay, this is 20 meter, so let me not write meter, because then you may confuse meter with the mass m. Okay, and that is positive here. Okay, so FB is therefore 20 10 mg plus 15 mg. Okay, now if you plug all the value, all the given value here, you can show that, so this is 10, small m is 1500, gravity is 9.80, and then this is 15, and then big M is 15,000, and then 9.80, and that is divided by 20. Okay, so let me erase this diagram. Okay, so this gives us FB is equal to 1. So my calculator give me this number, 117600 Newton. Okay, so 117,600 Newton. Okay, so this is FB. And how to calculate FA? It's easy now. FA is, I mean, from this equation you can solve FA. Okay, so 161700 negative 117,600. So this is basically 44,100 Newton. So FA is basically from this equation. Substituting the value of FB in this equation, you get FA. Okay. All right, very good. So the next problem is exactly same. Okay, so let's do it. If you understand this, the next problem is easy to solve. Okay. All right, so next problem here, we have similar to the beam. Okay, similar to the beam in the last problem. Okay, so we have this board. So this board is basically the same as the beam there. This lady is same as the printing press in the last problem. And these are the two beams, okay, that support these. Okay, now we can do exactly the same thing what we did. Now here, although we have two problems, here it asks us to calculate the same thing, FA and FB, first ignoring the weight of the board. So you can think that I mean, first you have to solve this problem, assuming that this has negligible mass. But let's first calculate this one, okay, and then come back this one. Okay, so we can first calculate this, and then for this one we can just ignore the mass of this board. Okay, but is basically the same thing. Okay, I will show you how. Okay, the first thing we have to do here is to draw a free body diagram very similar to the last problem. Okay, so the free body diagram, let me draw here. So this lady should have gravitational force. The board should have mass at the center of this board, and then there will be, let me say that there are two normal force. One is FA and another is FB. Okay, so one by the beam A, another by the beam B. Okay, now here there may be a problem, because you know that if the board is somewhere here, okay, and if so if the lady is not here, then there is no problem. But if it is not supported, if it is not hooked by something here, then when the lady is standing here, okay, it will not be in balance. Okay, so there is something here. Okay, but for simplicity, let's just consider the similar thing what we use in the last problem, and probably you will see that the FA is negative. Okay, FA is negative. If it is not negative, okay, if there is no force in this direction, so when the lady stands here at this point, it will not be in balance. Okay, but for simplicity, let's ignore that thing for the time being, and let's say that there is only a normal force here acting on the board by the beam, and that is FA. Okay, sign of when we do everything, you will see that the sign is opposite, and this opposite sign will tell you that the force is not the normal force, it is tightened or hooked or screwed by something here. Okay, so we'll see later. Okay, all right. So very similar to the last problem, we can write two equations. First, the Fy, okay, Fy equal to 0. Similar to that, Fa plus Fb will be Mg plus Mg. Okay, now for the first problem, when there is the no weight for the board, then you can just remove this, you can just plug this value equal to 0. But let me not do that, let me just do the number B, and you can do the number A, okay, by yourself. Okay, and similar to last problem, I can write something like this, and M is 28 kilogram and lady's mass is 52 kilogram, and this is 9.80. So altogether it will be 784 Newton. Okay, now again the tau equal to 0. So for the last, I mean, similar to the last problem, let me call this as our axis of rotation, and you see all the forces are perpendicular. So sine theta equal to sine 90 degree, which is equal to 1. So it's very similar to the last problem. So the lever arm for this one is 0. So this is this. Lever arm for FB is 1 meter. Okay, again I intentionally did not write the sign here. And then for Mg, the lever arm is so this is 1, and then so this is 4 meter long, right? The board is 4 meter long, so the center of the 4 meter is 2 meters. So the lever arm for the board is 2. Okay, you have to understand this, because this is 1 meter and this is 3 meters, so altogether it is, the board is 4 meter long, so the center of the 4 meter is at 2 meter. Okay, so many students make mistake here, make sure you understand this. And the lady is at the end, so it is 4 meter. Okay, and similar strategy that we used in the last problem, you can show that this is positive, this is negative, this is negative. Okay, so this is 0, and similarly that I mean here this is 1. Similar to the last problem, we can write this. Okay, so FB is equal to 2, M is 28 kilogram, G is 9.8, and then this is 4, the lady is 52 kilogram and 9.8. So altogether we get FB is equal to 2587.2 Newton. Okay, so this is the force and this is positive, so that's good. Now we have to calculate Fa. So similar to the last problem, we substitute the value of FB here, and we get something like this: 784 Newton minus FB. So 784 Newton minus FB is 2587.2 Newton. So what we get is negative 1803.2 Newton. Okay, so you see that Fa is negative, so it's not basically the normal force, it's it is something hold the board. Okay, so probably the screw So probably there is some screw here that is holding the board, okay? And that's why the force is negative. So it's not the normal force, but by using the same strategy we use in the last problem, we can solve it. But at the end, you see that the force is negative, and this negative force tells us that um, the 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 force is not normal force here. It's some downward force, okay, that holding this board. Now, if you ignore the board mass or board weight, so you see that um, it will be less because this is 0, okay. And then in this equation, the second equation, this will be also 0, okay. It's even simpler, okay. So you can try um, with the same strategy that we used in this problem in number B, and check that whether you get you can solve it. The result I already post in the solution, okay. So check your result with my result, okay. All right. The next problem I'm going to all right, so the next problem is a little bit complicated, and I am not doing this here, okay. So if you want to do it, I already post the solution, so you can go through it, and if you have question, you can come to my office hour and discuss. But because it is little bit complicated, I'm not doing this one, okay. But the solution is already there in the solution, I mean the classwork problem solution, okay. So I already posted, so go through it if you're interested. All right. Now again, this one is very similar to the last two problem, I mean number 3 and number 4, okay. So again, I'm not doing this one, but you should do that. So there will be no question in the exam like this, because this is a little bit complicated problem. So I'm not going to set this kind of complicated problem in the exam, but there may be question something like this, and it is very similar to number 3 and number 4, okay. So here, let me just briefly discuss it, and um, and then go to the next problem. Your job is to try it and check that whether you get the result what I got. The solution is already there, but please try yourself, okay. So I'm not going to solve it, but I'm going to give you all the information you need to solve this, okay. So here you see that it is exactly very similar to the printing press problem. So here you see that the beam that support another beam. So here, let's say this is the printing press, okay. So this is the printing press, this is the beam, okay, and this is the vertical, these two are the vertical beam, okay, and the length of this beam is L. All right, now what you have to do, you have to draw a diagram, force diagram, I mean the free body diagram. So this is the beam, the center of mass for this beam is this one, the center. So we have mg here, okay. So this is for this beam. Now the another beam, small beam, is here, okay. So it is half, so the mass is half of m, okay. So the gravitational force will be something like this, half of mg, okay. All right, so these are the two things, two gravitational forces, and then there will be a force, normal force, let me call it FB, and let me call it FA, similar to the last two problems, number 3 and 4, okay. So these are all the information you basically need. Then you can write very similar to the last two problem, you can write that FA plus FB equal to, I mean when Fy equal to 0, you can write that FA plus FB equal to half mg plus mg. Okay, and you know that m is equal to this. So from that you can calculate what is the sum of fa and fb. And then similar to that last two problem, you can also determine tau equal to 0. Okay, now choose one, either this point or this point as your axis of rotation, and similarly write all the terms for the tau. Okay, so you need the lever arm. For this one, if you choose this as your axis of rotation, the lever arm is equal to 0. For this one, okay, the lever arm is equal to L over 4. Okay, why it is L over 4? Because you see that this is equal to L over 2. Okay, and this is at half of L over 2. So half of L over 2 is L over 4. Okay, so this is L over 4, this is L over 2, and of course this is L. Okay, so these are the lever arm. So by using this, you can write the equation for tau equal to 0, and solve it for FA or FB, and then substitute the value of FA or FB, whatever you calculate, in this equation, and solve for the next, the other force. Okay, so it's exactly same. Okay, so try this, and if you have question, let me know. And if you have confusion how I solve it, please check my solution. Okay, all right. The next thing is the next two problem, actually next three problem, is about elasticity. Okay, all right. So we have a long steel piano wire, 1.6 meter long steel piano wire, and we are given the diameter of this wire. Okay, so how great is the tension in the wire if it stretches by this much when tightened? Okay, so we are given delta L. So this is delta L. Okay, this is L0, and this is basically related to A. Okay, it's not exactly A, but somehow it is related to A. So we have to calculate what? Force, tension force. Okay, now what is the definition of delta L for the tensile force? It is something like this. Okay, now if I solve it for F, it gives me something like this. F equal to EA delta L L0. Okay, so if I solve it for F, it gives me this. Okay, make sure you understand how I get these. Okay, all right, so E is a constant number, so you can get the value of E from the table I showed in the class. Okay, during exam time I will be giving the value of E, so you don't need to be worried about the value of E. And from the table I got E equal to E for steel, so here we use a steel. Okay, so E for steel is 200 times 10 to the power 9 Newton meter square. So you see we are given most of the quantities directly or indirectly. Okay, so our job is to plug the values, given or known values, to this equation and find the tension force. Okay, so this is in SI unit, it's fine. L0 is in SI unit, also fine. Delta L is not in SI unit, so delta L is 0.25 centimeter. So let me convert into meter by this. Okay, but A we do not know directly. So what is the cross section area? For a circular cross section, area is this pi r square. Now again, here we need the radius, but we are given the diameter. So what is the radius? Radius is the half of the diameter, so it is pi d by 2 square. Now we are we know everything. Okay, so pi d is 0.20, okay, times 10 to the power minus 2, okay, in meter. So it is in centimeter, so I have to convert it into meter, and by multiplying by 10 to the power minus 2, it is now in meter. So if you plug all this value in your calculator, it should give you some number, something like this: 3.14 times 10 to the power minus 6 meter square. Okay, so you see that now in this equation you know everything except f. So plug this value, this value, this value, and this value, and check whether you get this value or not. Okay, 981.3 Newton or not. Okay, all right, so this is A. Number B, let's try number B. Okay, number B tells us approximately what tension force would break it. Okay, so it asks us to calculate the maximum force, and you know that maximum force is related to this equation, right? So F max is ultimate strength. Okay, so this is ultimate strength times A. So A is this one already, and ultimate strength for the tensile force of steel is 500. Okay, so if you go to the table again, you can see that the ultimate strength for tension is this for the steel: 500 times 10 to the power 6 Newton per meter square. Okay, so by plugging these values in your calculator, you can show that the value is the maximum force for which this piano string will break is this Newton. Okay, so this is the maximum tension force the piano can hold. I mean, the piano wire can hold. Okay, all right. All right. The next problem is about the change in volume. Okay, and if you remember, the equation we derived there is this one. Okay, so this is the equation we derived there, and it tells us that how much pressure is needed. So delta P we have to calculate to compress the volume of an iron block by 10%, by 0.10%. Okay, so we have to calculate when delta V by V0 equal to this. Okay, so it says that when delta V to compress the volume of iron block by 0.10%. So this 10% is basically the value of delta V. So the delta V over V0 is this. Okay, so this is basically 10%, and you know that percent is equal to 1 over 100. So this is basically delta V by V. Okay, so this is 10 times 10 to the power minus 2. Okay, all right. For iron, B, the bulk modulus is you can find it from the table, okay, either from my lecture or from the textbook. And B for iron is this 10 to the power 90 times 10 to the power 9 Newton per meter square. So when you plug these values here in this equation, you can solve it for delta P. So delta P will be delta V over V0, actually negative, and then times B. So it is negative 0.10 times 10 to the power minus 2, and B is 90 times 10 to the power 9 Newton per meter square. Okay, and there will be a negative sign here also. Okay, so because delta V is less, okay, delta V is, so delta V is something like this. So the final volume minus initial volume. Okay, so final volume, it says that the compress, okay, so it says that how much pressure is needed to compress the volume of an iron block by 0.10%. So this is small, okay, and this is large. Okay, so small minus large is negative. Okay, so it is basically negative 0.10%. Okay, so you should have a negative sign here, so I forget to put a negative sign here. Okay, so this negative and this negative cancel out, so what we are left with is this 9.0 times 10 to the power 7 Newton per meter square. Okay, so you can compare this by this. Okay, check that what is this pressure. Okay, and you see that this is higher than this one, and you see this is about 900 times of atmospheric pressure. So this is the atmospheric pressure, so this value is 900 times the atmospheric pressure. Okay, all right. All right, so this is the last problem, and this is, I think, one of the easiest problem in this chapter. Okay, so it says that the femur bone in the human leg has a minimum effective cross-section area about this. Okay, so the area is already given, so this is the area, and how much compressive force can it withstand before breaking. Okay, so basically we are again need to calculate F max. Okay, so you know that F max is equal to ultimate strength times the area, and ultimate strength for human bone when it is under compression is equal to 170 times 10 to the power 6 Newton per meter square. And again, you can find this from the textbook table or from my lecture. And A is this. Okay, so the force here you find by multiplying these two is something like this, 51,000 Newton. Okay, it's a huge number. Okay, so the bone will break if this mass force is applied, basically. All right, so that's it for this chapter, and with this I'm going to stop.